In this video, I'm going to go over the pre-calculus second semester final review. So in our first unit, we talked about trig identities, and part of that was verifying, where you're trying to show one side equals the other. So the first task is to decide which side. So looking at this, there's more things I can do here, so that's going to be the side I'm going to choose. Then to turn everything in terms of sine and cosine. So I'm going to change this tangent into sine squared theta over cosine squared theta. And that one's just sine still. Okay, next I want to get a common denominator. So I'm going to multiply this one by cosine squared over cosine squared. So this will be sine squared theta cosine squared theta all over cosine squared. Okay, now that we have a common denominator, we can combine these things. Okay, next I can factor out a sine squared. So I'm going to have sine squared theta, which will leave me with 1 here minus cosine squared over there. One minus cosine squared is sine squared. Okay, then I want to look at what I'm trying to show. I'm trying to show tangent times sine. So what I'm going to do is just pair these two together and make this sine squared theta over cosine squared theta times sine squared, which is tangent squared. Okay, and this one, everything's in terms of sine and cosine. This we can do more things with, so I need to get a common denominator. So I'm going to multiply this one by 1 minus sine over 1 minus sine, and multiply this one by 1 plus sine over 1 plus sine. Okay, which gives me this. Then I'm going to combine them, and I'm going to distribute through the cosines. Okay, sorry, I realized I forgot the original denominators there. Anyway, so we distribute through the cosines, and then when we get this denominator, when we FOIL it, you're going to have 1 plus sine of x minus sine of x minus sine squared. So when we combine everything, this and this cancel, this and this cancel. So in the top, I have 2 cosine x. In the denominator, we have 1 minus sine squared, which of course is cosine squared. So this reduces to 2 over cosine of x, which is equal to 2 secant of x. So getting a common denominator and then just working your way through it. All right, next we have the binomial theorem. So the binomial theorem, the first step is to take whatever row of Pascal's triangle we are interested in. So you will be given a Pascal's triangle. So if this is 4, we want the 4th row, which is going to be 1, 4, 6, 4, and 1. So I do one of those kind of as a placeholder. Next we take whatever is first, so the x squared, raise it to this power, and then repeat that in descending order. So 3, 2, 1, and none. Then we'll take the second thing, which is negative 2y, to increasing powers. So there's not one here. Negative 2y here, negative 2y squared, negative 2y cubed, and negative 2y to the 4th. Now we need to simplify. we'll do this in a couple steps here. First, we have the power to the power, so that's going to be x to the 8th. Here, this negative is being raised to an odd power, so this next term is going to be negative, and then I'll multiply the 2 and the 4 to get 8, and then we have x to the 6th and y. This next one I'm going to do in 2 steps. So this is going to be 6 x to the 4th, and then negative 2y squared is going to be 4y squared, and it's positive. The next one is going to be odd power, so that makes this negative. 4x squared times 2y cubed is going to be negative, I already dealt with that, 8y cubed, and then this will be a positive 16y to the 4th. So my last answer is x to the 8th minus 8x to the 6th y. 6 and 4 make 24. 4 and 8 is 32. And 16y to the 4th. So your final answer should alternate because of the negative. We've got the powers of 2. Don't forget to raise those powers. And then, so each term should have a coefficient, x to some power and y to some power. In vectors, so what we have here, a plane travels at 275 miles per hour at a bearing of 310. There's a wind blowing out of blowing at a bearing of 65 degrees at 30. And this is 065, not 60. It's, yeah. So first I'm going to draw vector diagrams of each. Okay, so we have a bearing of 310. So bearings due north is 0, that's 90, 180, 270. So 310 is going to be over here. Okay, so this is the 310. What we're interested in is the reference angle. So this is going to be 40, because it's going to be 40 degrees past there. For the wind, it's at a bearing of 65. So 65 is going to be like here. This is the 65. The reference angle that we need is 25. Next, we're going to write the component form. So you can use whatever notation, just as long as it's clear what's happening in the x direction and what's happening in the y. So this one is going to be a negative positive. So my first is going to be negative. We do the magnitude, which is 275, times the cosine of the reference angle, which is 40. My y component, and I'm going to use the I and j notation. Okay, the vertical piece is positive, and then it's going to be 275 sine of 40. And I'm going to label that with a j. Again, you can label it as long as it is clear what is x and what is y. Now we're going to type it into the calculator and make sure your calculator is in degrees. Okay, so that's what's happening with the plane. It goes negative 210 in the x direction, positive 175 in the y. This next one, the reference angle, we said was 25, and this is going to be a positive because it is in fact in the first quadrant. Okay, so we have the magnitude cosine 25, magnitude sine 25. Again, we're using the I and j. Type it into the calculator. So that is our wind vector. Now we are going to add. So you're going to add this and this. So we're going to add these two numbers and these two numbers. So you add the x's, add the y's. So this is the component of the sum. Now we're going to turn it back into what's actually happening. So what is the true ground speed, which is going to be the magnitude of this vector, and what the bearing is. Okay, so for this, we're going to do the square root of this squared plus this squared. Okay, so this is our ground speed. For the bearing, we're going to start with tangent inverse. So I'm going to do the tangent inverse of the y over the x, or the 189.446 over, and I'm going to ignore the negative, 183.473. This gives us an acute angle of 45.918. Okay, now we have a little work to do here. My result was a negative positive, so that means we're going negative 183 here and 189 here. So this is my resultant vector. The 45.9 that we just found is the reference angle, is that. We want the bearing from due north. So in this case, we're going to take that number and add it to 270. So my true bearing is 315 degrees, 0.918. Last free response problem. We have a power series, which is an infinite geometric series. The common ratio, what we're multiplying to get from term to term here, is 1/3 x. So we know we can find the sum of an infinite series if the common ratio is between -1 and 1. So I'm going to take -1, put 1/3 x in the middle here, and then just multiply by 3. So my interval of convergence is -3 to 3. Then the rational function is just a1 over 1 minus r. So a1 is 3 over 1 minus 1/3 x. And you can leave it just like that. Okay, next we have another verifying problem. So these are the multiple choice questions. These are all no calculator, so keep that in mind as you go. So first thing I'm going to do is get a common denominator. So multiply this by sine plus y over sine plus y. Multiply this one by sine minus y over sine minus y. Okay, don't have a whole lot of room here, so we're going to work sideways. So sine minus sine is 0, and then we're going to have 1 minus -1. So on the top I have 2. When we FOIL this denominator, we get sine squared minus 1. Well, this is equivalent to negative cosine squared. Okay, which is equivalent to -2 secant squared. For the next problem and the next problem after that, we are going to be using the trigonometric identities. So on your formula sheet for this one, we're going to be using the sum and difference identities, specifically the difference for sine. Okay, so the sum and difference identities, sine A plus or minus is this whole thing. So since this is minus, this will be minus. So I'm going to write that out first. So there's the general formula. Keep in mind these are all multiple choice, so the amount of work you show is up to you. Then I'm going to substitute in pi for A and theta for B. So we get that. Then you're going to want to use your unit circle to evaluate those to the pi's. So sine of pi, the y value here is 0. The y value, the x value there is -1. So out of all of this, the negative makes this a positive, so this is equal to sine of theta. In this next section, we're going to be using the double angle identities. So on your formula sheet, we're using the double angle identities. We're going to be using sine, cosine, and I'm actually not going to use the one for tangent, and we'll see why. So first, sine 2 theta is 2 sine theta cosine theta. Well, I know what cosine of theta is. I do not know what sine of theta is. But if you'll recall, we figured out that we can find this using a triangle. So I'm going to call that angle theta. And then here, if cosine of theta is 5 over 13, I'm going to say the adjacent side is 5 and my hypotenuse is 13. And I want to find that. Okay. So you might know this Pythagorean triple, but if you don't, we can use the Pythagorean theorem. So 25 plus x squared equals 169. Subtract to get 144, so x is 12. So my new piece of information is that sine of theta is going to be opposite over hypotenuse, so 12 over 13. So now we just put those in here. Sine is 12 over 13. Cosine is 5 over 13. So 2 times 5 is 10, so we get 120 over 169. Okay, next from the formula sheet, cosine to theta. There's 3 options. I'm just going to pick the first one, which is cosine squared theta minus sine squared theta. Then I will substitute my cosine squared minus my 12 over 13 squared. So I'm going to leave some space for tangents. I'm going to work sideways. So we're going to have 25 over 169 minus 144 over 169, which is a negative 119 over 169. Okay, last for tangent. There is a formula, but once we know sine and cosine, this is just going to equal to the sine of 2 theta over the cosine of 2 theta. Okay, which is going to be 120 over negative 119. Next, we have solving problems, which relies on a lot of the same things we've been using. First, looking at this, I've got both sine and cosine, which is not ideal. So my first step is going to be taking this cosine and turning it into a 1 minus sine squared. Then I'll distribute through. So we have 2 minus 2 sine squared x minus sine of x plus 1. Well, the 2 and the 1 are going to be 3, but I don't like the fact that I've got a negative in front of these. So I'm going to move it all over here. So that'll be a positive 2 sine squared, a positive sine, and a negative 3. Okay, well now we just need to figure out what factors will give us this. So it's going to be a 2 sine theta and a sine theta. One of these has to be positive and negative if they multiply to be 3, and they have to be 3 and 1. So running through the different possibilities, if I have a plus 3 minus 1, that middle term is negative 2 plus 3, which gets the positive 1. So either 2 sine theta plus 3 equals 0, or sine theta minus 1 equals 0, which means sine of theta equals negative 3 over 2, or sine of theta equals 1. Well, between 0 and 360, sine is never less than 1. So that one does not have a solution. Sine is 1 only once at the top of the table at 90 degrees. The last one, quite simple. Cosine of x is 1/2. For 0 to 360, you're looking at your unit circle. The x values are 1/2 at 60 degrees and at 300 degrees. Okay, next we're going to draw some vector diagrams and find the reference angle. So standard position is our unit circle measurements. So the positive x-axis is 0, 90, 180, 270. So this one, standard position's 140, is going to be over here. This measurement is 140. The reference angle is the angle from the x-axis, which is going to be this angle here, which is going to be 40. So our reference angle is 40 degrees. Bearing, and we've already seen this with the plane problem, is measured from due north. So this is 0, this is 90, this is 180, this is a bearing of 270. So a bearing of 300 goes all the way around here. This is 300. My reference angle is this angle, which is going to be 30. Okay, so next we're going to figure out, we're going to make numbers here so that the vectors are perpendicular and so they are parallel. Well, if they're perpendicular, that means their dot product equals 0. The dot product is the product of the x's, so -1 times k plus 4 times 12, and we want that to equal 0. So my k value will be 48 to make perpendicular vectors. For parallel, what I'm going to do is switch one of these and change the sign of 1. So I'm going to make this -12k. That would be perpendicular. These two are perpendicular. So if these two are perpendicular and these two are perpendicular, these two are parallel. So now I'll do the dot product with those two. So -1 times -12 plus, plus 4 times k. Set that equal to 0. So 12 plus 4k equals 0. 4k equals -12, which means k equals -3. Okay, next we're going to identify the ordered pair that goes from this point to this point, and then we're going to find the magnitude. Well, just think about taking a trip. If I start at -9 and I go to 1, that means my x coordinate is going to be 10 because we're going positive 10 from -9 to 1. If I'm going from -1 to -3, that means I'm going down 2, so my y component's -2. The magnitude is just the square root of 10 squared plus 4 squared, 2 squared, which is 4. So this is going to be square root of 104. Okay, so these next two I'm going to kind of talk about together. We want to write the parametric equation of one in slope-intercept, and then we're going to write the slope-intercept form of something in parametric. So this is what the parametric equation looks like. The general formula is x equals x1, I'm just going to call it delta. We added an a1 t. Y is y1 plus a2t. A point on the line is any x1, y1. So any points on the line can go there. And then a1 A2 is our direction vector. So this is going to be my change in x, this is my change in y. So putting that with the line, I know my slope is, I'm going to put the negative with the 4. It actually doesn't matter which. Well, that is delta x over delta y. Okay, so for my lines, we're going to have an x equals and a y equals. We're going to pick any point on the line. Well, there's an infinite number, but the easiest is going to be the y-intercept. And then I'm going to add my change in, apologies, this is flipped. Rise over run, right guys? Delta y over delta x. So my change in x is 5. My change in y is negative 4. This would be one option. Keep in mind this is multiple choice. The negative could have gone with the 5, which would make this plus. That would be valid. But these are one example. You just have to find the right one on multiple choice. Here we're going to kind of work backwards. Okay, so I know my point on this line is 6, 7. The slope is going to be delta y over delta x. Let's not make that mistake again. So my change in y is 5. My change in x is 8. Then what I'm going to do is actually put this in the point slope form of a line, which is y minus 7 equals 5/8 x minus 6. So y minus 7 equals 5/8 x minus 30/8. So 15/4. And then I'm going to add 7, which would be 28/4. So 28 minus 15 would give me a 13/4. Okay, next we're going to graph in polar. So I'm going to call this point A to 120. So you're going to go out to and then go over to 120. Okay, when we have a negative positive, you can go to 7 pi over 4, which would be here, and then go negative 3. Or you can go to negative 3 and go counterclockwise 7 pi over 3. Either way, we're going to end up here. Call this one C. When we have a positive negative, rather than going 120 this direction, we're going to go 120 this direction. And go up 1, 2, 3. And then the last one, a negative, negative. You can go to negative pi over 6 and then go negative 2. Okay, or you can go to negative 2 and go clockwise that measurement. Okay, next we're going to be graphing lines and circles, so just basic equations. Negative 310 is going to be the same as positive 50 degrees. This would be 45, so negative 310 is going to be just a little bit more than that. Okay, so negative 310 would be this measurement here, but it's all the same line. R equals 3, you're just going to go out to 1, 2, 3, and graph that line, or circle. Okay, next we're going to be converting between rectangular coordinates and polar, and we're going to look both directions. So going from rectangular to polar, the R value is going to be the square root of the x squared plus y squared. Theta is going to be the tangent inverse of y over x in the correct quadrant. So let's do some of these. So first, our r is going to be the square root of root 3 over 2 squared plus 1/2 squared. That's going to be the square root of 3/4 plus 1/4, which is 4/4, which is 1. Square root of 1 is, of course, 1. Theta is going to be the tangent inverse of 1/2 over root 3 over 2, which when you do this math, you end up with tangent inverse of root 3 over 3. We want this in quadrant 1. So tangent is root 3 over 3 at pi over 6. Okay, not a bad idea to put those tangent values on your page. So my coordinate is 1 pi over 6. This second one, it's a little tough to tell, but these are supposed to be negative, negative. So this is quadrant 3. Okay, so we'll do our r value is the square root of root 2 squared plus root 2 squared, which will be 2 plus 2, which is 4. Square root of 4 is, of course, 2. Theta is going to be the tangent inverse of negative root 2 over negative root 2, which is tangent inverse of positive 1, which occurs at both pi over 4 and in the third quadrant, 5 pi over 4. So my coordinates here are 2, 5 pi over 4. When we're going the other direction, x equals our cosine theta, and y equals our sine of theta. Those are our two conversion equations. So super easy. X is equal to 3 cosine 45. Y is equal to 3 sine 45. Use your unit circle. Cosine of 45 is root 2 over 2. The sine is also root 2 over 2. So I multiply those together. I'll get my coordinates 3 root 2 over 2. 3 root 2 over 2. Okay, this one. X equals negative 2 cosine negative pi over 3. Y is going to equal negative 2 sine negative pi over 3. Okay, negative pi over 3 is just down clockwise pi over 3. So that's going to be equivalent to 5 pi over 3. So the x value there is 1/2. So this is negative 1. The y value there is negative root 3 over 2. So this is going to be a positive root 3. So we get the coordinates negative 1 and positive root 3. Okay, in this next section, we're going to be converting equations rather than coordinates. If we have a polar equation, we want to try to get our sine theta or cosine theta, which I can get by multiplying sine. And just like with the coordinates, our sine theta is y. So this is y equals 5. This one, I'm going to first start by foiling this part. Okay, the 9 and 9 cancel. So I'm going to write this as x squared plus y squared equals negative 6y. Then I'm going to replace this with r squared and this with r sine theta. And then I can divide both sides by r. Again, keep in mind this is multiple choice, but that's our answer. Next we have the polar form of complex numbers. So when we're multiplying, dividing, or doing powers, when you're multiplying, you multiply the two r values. So I'm going to multiply 3 and 4. And we're going to add the two theta values. So just to get a common denominator, this is 2 pi over 6. So I'm going to add 7 pi over 6 plus 2 pi over 6. Again, this is multiple choice, so the amount of work you show is really up to you. So 3 times 4 is 12. And then we have cosine 9 pi over 6. Which on a multiple choice is not going to be this labeled. It'll be the simplified. So I'll divide both by 3 to get 3 pi over 2. Okay, for division, you're going to divide the r's and divide the thetas. Okay, so I'm going to take c1 over c2. So we're going to have 3 over 4. And then we're going to have cosine theta 7 pi over 6 minus the other theta. Okay, so this ends up being 3/4 cosine 5 pi over 6, which happens to be one of our unit circle values. Okay, we want to answer in rectangular form, so I need to go ahead and simplify this. My x value at 5 pi over 6 is going to be negative root 3 over 2. My y value is going to be positive 1/2. And then we'll go ahead and distribute. So this is going to be negative 3 root 3 over 8 plus 3 over 8i. The next one's going to be the reverse of that, but we want our answer in polar form. So we have 4 over 3, and then when we do 2 pi over 6 minus 7 pi over 6, we get 5 pi over 6. Then we want to write the equivalent positive form. So our final answer here would be 4/3 cosine 7 pi over 6 plus I sine 7 pi over 6. So you can either think about this graphically or just add 2 pi, which would be 12 pi over 6. Okay, next we're going to use powers. So I'm going to take C1 and raise it to the 4th. So we'll take the R value, which is 3, raise that to the 4th power. Then we're going to multiply the theta, which is 7 pi over 6 times 4. So we get 28 pi over 6. Okay, so we've done the work here, but now we need to get this into rectangular form. 3 to the 4th is 81. First, I'm going to reduce this fraction and make this 14 pi over 3. Okay, which is not on the unit circle. Okay, so what I'm going to have to do is subtract 2 pi, which in this case is going to equal 6 pi over 3. Okay, so in this case, I'm going to do that twice. I'm going to 6 pi over 3 would get me to 8 pi. Do that again to get 2 pi over 3. Okay. So then we use our unit circle. Cosine of 2 pi over 3 is negative 1/2. The y value there is positive root 3 over 2. So my final answer here is going to be negative 81/2 plus 81 root 3 over 2. Our next unit was sequences and series, and we started off with factorials. So when we're simplifying, you want to take the bigger thing and write it in terms of the smaller one. So the numerator is just going to be n minus 1 factorial. For factorials, we have the first number times the number 1 less than that, which would be n, times the number 1 less than that, which would be n minus 1 factorial. So those will cancel, and I'm left with 1 over this times this, which would be n squared plus n, would be your multiple choice answer you're looking for. Here, we can rewrite this as n plus 1 times n factorial over n plus 1. So this simplifies to just n factorial. Okay, we're going to look at different situations to decide if it is a permutation or a combination. In a combination, the order does not matter. Permutation order does matter. So a safe has a 4-digit combination to unlock it. If numbers cannot be repeated, how many combinations are there? This is, ironically, order does matter. You can't put them in just a random order. They must be in the correct order. So a combination lock is actually a permutation. Okay, an omelette station is running a special on omelets. How many 3-item omelets can be made from 10 ingredients? Well, it doesn't matter what order we put them in. This is a combination. In the Olympic luge competition, there are 23 competitors. How many ways can gold, silver, and bronze be awarded? Order definitely matters here. And then the lottery, it doesn't matter what order the numbers are picked, just that you've picked the correct 6 numbers. So this is a combination. Okay, next we're going to write an recursive and explicit. So recursive, we always want to say what A1 is, and then we say how we want to get to the next term. So here what we're doing is we're subtracting 5. So to get to an plus 1, we're going to take the term before it and subtract 5. Explicit, you want to be able to plug in 1, 2, 3, 4 to get those values. But if we know a specific type, so this one is arithmetic, we can just use those nth term formulas. So my an would be a1, and these are on your formula sheet, plus n minus 1 times my common difference, which when you simplify this, because again this is going to be multiple choice, is going to be negative 5n plus 9. Okay, the next one is geometric, because we are multiplying. So still for the recursive, a1 is negative 1, an plus 1, we are taking the previous term and multiplying it by negative 3. So negative 3 times an. For the explicit, the general formula is an equals a1, which is negative 1, times the common ratio, which is negative 3, to the n. And that's good for simplifying. You could write it as negative this, but the negatives don't multiply, so be careful there. Okay, so we're going to find A3 and A6 for two different types of equations. One is recursive, one is explicit. So for the recursive, to get A3, you need A2, and so on. So we actually have to do the whole thing here. A2 is going to be 3 minus 2 times A1, which is negative 1. So that'll be 3 plus 2, which is 5. A3 is going to be 3 minus 2 of that, 5. So 3 minus 10 is negative 7. A4 is going to be 3 minus 2 times negative 7. So that'll be 14 plus 3, or 17. A5 will be 3 minus 2, 17. And A6 is 3 minus 2 times negative 31, which is 65. So our two answers are but if it's explicit, all we have to do is plug in the number. So A3 here is going to be 3 times 3 minus 1. So 3 times 2 is 6. To get A6, we have 6 times 6 minus 1. So 6 times 5, which is 30. Okay, next we're looking at, are they arithmetic, geometric, or neither? So this one is just kind of bouncing around. It's neither. This one, we're multiplying by 2, 2, 2. So since we're multiplying by 2, this is geometric. Here we're adding 2, so this is arithmetic. So in an arithmetic series, if A3 equals 7 and A7 equals 37, what is A1? Which is 7, A4 we don't know, A5, A6, and A7 is 37. So what I'm going to do for this is renumber, make this A1, which makes that A5. Okay, so in my nth term formula, I'm going to say 37 equals A1 plus 5 minus 1 times my common difference. So I can subtract 30 equals 4D. So my common difference is 30 fourths, or 15 halves. Okay, then I'm going to go back to my original numbering structure and either plug in this one or this one, it doesn't matter. So if I say 7 equals A1 plus, if I'm plugging in 7, that means that's the third term, so n is 3. Common difference is 15 halves. So it's going to be 2 times 15 halves, which is 15. So my A1 is negative 8. Next, we want to form a geometric sequence with one geometric mean between 2. So A1 is 2, A2 is some number I don't know, and then A3 will be 72. So we're going to use the 72 equals A1R to the n minus 1. So 36 equals R squared. So R is 6. So then if I multiply this by 6, this would be 12. And that would be my geometric sequence. Okay. Next we get into sigma notation. So here I don't have a function versus this one I do. So when I plug in 2, we have 5. When we plug in 3, we get 5. When we plug in 4, we get 5. 5, we get 5. 6, we get 5. 7, we get 5. Okay, so we have 6 5s, or a sum of 30. Expand this one. So this is 2 times 6 plus 2 times 7 plus 2 times 8 plus 2 times 9 plus 2 times 10. It could be written like this. Or 12 plus 14 plus 16 plus 18 plus 20. Notice it doesn't say to find the sum, it just says to expand. So this be expanded. This next one, write in summation notation. So there's different ways we can do this. Okay, so I'm going to start with my general formula. We've got 2 on the top here, and then we have the odd numbers. So the equation 2n either plus 1 or minus 1 will give me the odd numbers. If I do minus 1, that means I'm starting at 1, because 2 times 1 minus 1 would be 1. And you can always double check. And this is plus dot dot dot, so to infinity. Okay, here we want to find the sum of the infinite series if it exists, which means we need to look at the common ratio. Here we're multiplying by 3 over 4, so my ratio is 3 over 4, which means the sum certainly does exist and is a 1 over 1 minus r. So that's going to be 2/3 over 1 minus 3/4. So that's 2/3 over 1/4, which is going to be 8/3 when we multiply by the reciprocal. This one, my common ratio, we're multiplying by 4 on the top, 2 on the bottom, and it's alternating, so negative 4 over 2. So there is no sum, because that is definitely not between -1 and 1. In this section, we're determining whether the type of series and whether it is convergent or divergent. So here, 2/3, 1/3, 1/6 is infinite geometric. Okay, the ratio is 1/2, which means this is convergent. Okay, here, this would be 2 over 1, 2 over 2, 2 over 3, 2 over 4, which is the harmonic series, which is always divergent. Okay, this next one we're multiplying by 4 on the top and 2 on the bottom, which is an infinite geometric. However, this one is divergent. This one we're multiplying by 2 on the top and 2 on the bottom, so our ratio is 1. So this is actually divergent, and it would be geometric, or arithmetic, I guess. Next we have limits. So for these polynomials, we're looking at the degree. So the degree is the same, so it's going to be the ratio of the leading coefficients. Here the degree is bigger on the top, so we would say this one does not exist. This one, the degree is bigger on the bottom, so it goes to 0. For these exponentials, if the base is between -1 and 1, it goes to 0. If it's bigger than 1, then it goes to infinity or does not exist. E is about 2.718. Pi is about 3.14. So that number is less than 1. So that is 0. So that is your pre-calculus final review.